Hello, classmates. I'm Stephen Brennan, and I'm here today to show you my Excel spreadsheet. I don't have a face cam yet, but I just bought one on Amazon, so next time we do this, I should have one. So, no need to worry about that. Okay, so problem one. Not problem, uh, scenario one. We were talking about Earth's gravitation, or Earth's rotation speed, its orbit around the sun, our solar system's orbit around our cluster, and how if you just zoom out far enough, you'll realize we're technically going really fast. It just doesn't feel like it. And yeah, I like this chart because it like really shows the actual speed we're going and how little we can perceive our all this that's going on when you compare to our little 0% Earth's rotation. And this is just the same thing, just with a bar graph. You can just see the real big details in it about which one is fastest. And of course, we only went to the local group here, and we stopped there. But in theory, we could just keep going and going, and it just wouldn't stop for as much as we can see so far. But that'll change in the future, I think, with better technology with telescopes and the such. With the universe scaler, I chose Hoover Dam. That really impressed me because I never really thought about how tall the Hoover Dam is. Um, Especially compared if you look at the pyramids and the Eiffel Tower specifically. That just really surprised me with how big the Hoover Dam is. Um, in my eyes, measurement is relative to what you want to consider. I mean, if it's something that doesn't really matter on a scientific scale, then I don't see myself using these kinds of measurements for the solar system or the Earth and the such. Um, but of course, scientifically, yes, I say you have to consider that stuff. In scientific notation, it's just a way to it's just the best way to shorthand a really big number. And same with the minus e, I think you said. It's just for incredibly small numbers. Okay, for number two, we're talking about the scale of pi, no, not pi, bar graphs, and how just changing the scale, it can trick people into thinking that something seems like a rather big deal when it really isn't. For me personally, I never really got tricked in these kind of things. I mean, if you just look at the data right here, it's very obvious that if you see the data here and then you see a graph here like this, it's obviously trying to trick you. And I just I just feel bad for the people who do fall for something like that and don't look at the axes, or just they just look at a bar and they're not even concentrating on the actual data on the side of it. And then the bowlers here. That oh yeah, that was the unemployment rate. I guess I forgot to mention. In the bowler score here, it's just the same thing. If you zoom in, it looks impressive, but then when you start from zero, it's basically the same. On a cosmological scale, everything is close. It's all about perspective. It just like well, never mind. I won't get into that. But and then down here, it's just the same misleading information just with pie charts. Um, Pie charts I can understand a little bit more misleading than uh, bar graphs that have the data right here. Um, this is obviously just misleading when 10 million and 50 million look basically the same. And this is the correct information right here. it's just it's just incredible that somebody would even attempt to trick people like that. Um, and usually when people are trying to mislead somebody on purpose, it's usually for their own gain for the most part. Obviously. And then this graph, the Cartera graph, I never seen a pie graph like this ever before. I wouldn't even trust looking at this. I mean, that's just not a pie graph. It's just nothing I've never seen before. Uh, but when it comes to all this together, you just look at the source. For me, I just always look for the source and the information. So so you get the real information, and like you're not tricked by something so minuscule as a 0.02% right here with the Clintons or the Clinton and Bush. Uh, so yeah, number 3. Oh, this was a fun long one. The amount of Americans that have health issues, specifically obesity, type 2 diabetes, and high blood pressure. Um, right here, it's showing the percentages of people who have obesity, type 2 diabetes, and high blood pressure in comparison to the entirety of the United States, which is 326 million. I almost said billion. So yeah, these are pretty high numbers. And then these ones, it just took people, Americans that have obesity, type 2 diabetes, and high blood pressure, and we did math and such to take a percentage out of that chunk, which is only 63% of Americans. And I don't know why, but when I was following your video, it wouldn't round like this one in your video. It was rounding to 3.1, and it wasn't doing that for me. I don't know why. All the math's correct. I double, triple checked. It just I had to make the decimal point here just change a little so it would be accurate. Like right here, I just went ahead and wrote 3.1 because that's what it is. It just Excel wasn't rounding it. Then when it comes to the Venn diagrams, we took this number of all the people that have obesity, type 2 diabetes, and high blood pressure, and we put a number on them. Oh, looks like my graph moved a little. Let me move that back a little. Oh, I'll fix it later. And it's just taking the three different types of people and overlapping them with the correct data that we used here. Then you asked us to find, or not find exactly hard data, but explain how it could be possible for stuff like this to differ from state to state. The probabilities differ from state to state because of many different variables. For instance, the ones I could think of were annual income for food and health resources. Are there any healthy alternatives nearby, and can you afford them? They go hand in hand. And what's most convenient at the end of everyone's busy day? Okay, the next one, the height of people in inches with army recruits and mall shoppers. The tread line is just generalizing of the progress or in this case, the consistency of height in inches. Army recruits are generally tall and consistent, so the points and the tread lines are very tight knit. They're close together. Where the mall shoppers fluctuate with it being random. The tread line and the points just they're rarely close together because if you take something that's that random, it's just gonna be that random. Uh, it seems the general height differs around a 4-inch area for the mall shoppers. Or no, I'm sorry, the standard deviation 4 inches with the army recruits with the box and whisker plot box. And the box and whisker charts really are just like the tread lines. When you look at the army one, it's it's very tight, just like the tread line up here, because it's very consistent. Where you look at the mall shoppers, and it's just like the tread line. It's just very wide and random. And for me, I assumed this was very consistent because I assume there are certain types of people that join the army. And like you need to meet some criteria when it comes to health reasons. And I just feel like that's why it was consistent, where once again, the mall shoppers are just completely nitpicked out of random. It's just whoever walks in. Number 5, the sleep patterns of Duke University. The mean here and the standard deviation you gave us that, which let us work on this bell chart. I think it was called the bell chart. Don't remember. Um, I'm pretty sure it was a bell chart, but it's basically saying the highest peak of the bell chart. That's the most average number of scholars in Duke University that get that much sleep, which in this case was 6.7 hours. And then each one goes down about goes well it goes down on both sides, the average by the standard deviation, which in this case is 2.03 hours. Sorry, I was interrupted. Where were we? I think we were talking about this. Yes, the average was 6.7 hours, which was the highest peak, and it went down both sides by the standard deviation, which is 2.03 hours, and kind of guesstimated that with this. Or not, well, this isn't guesstimation. The actual plotting of the bars are guesstimation on my part. For me personally, I probably fell around the little more than 8 hours mark. I usually sleep that much every night, except for once in a blue moon. Usually it's 9 to 11 hours, but that's very, very rare. This was just the math for us doing this situation here. Or no, I'm sorry. I meant this is what we use to make the graph itself. All of this math that Excel happily helped us out with. The bell graph is a simple graph, but I like it. Oh, whoops. I think I'm messing this up. Fix that later. Um, so the chart below about the annual income, the annual family income, as it says on the axis, the graph, the average it says is $49,445. And it's obviously skewed to the right down here, and then it's just compiled at the very end, which I'm not sure if I would trust getting my information from a graph like this because it just kind of stops and left for your own mind to consider. What's next? Then number 6, Mr. Elon Musk. I've been following him around for years. Well, following around on Twitter, I mean. um, so this was about his flamethrowers, if you want to call them that. I call them glorified blowtorches. Um, but each to his own. The y-intercept is negative because of the initial investment for the actual building of the parts, the flamethrowers themselves. It's just inevitable that you have to invest to make a profit. I think it would be a good thing once you hit that bottom dollar there, because once you hit it, as long as people keep buying it, of course, and nothing happens on that department, you're just gonna go nowhere but up. And as Elon definitely did with these profits, and by 260 flamethrowers, he was already over 90 grand, which is insane. um, but yeah, when you're doing something like this, you got to make an investment to turn a profit. Because if you got to lose some of it for a little bit amount of time at least to make a profit. Although in Elon's case, he has so many fans that honestly, like all this, like here to probably like round $40,000, that he probably met that in like 3 days or something. Because I remember they sold out fast when he got that out there. And then it says here, uh, we did the math on that. Oh crap, I messed it up again. Um, anyway, it took 203 flamethrowers exactly, because you can't have part of a flamethrower. At least I doubt people would want to pay for that. Kind of a ripoff. It took 203 to make his first profit, which I would tell you what that was, but I just messed up the cell. So anyway, it was around $300. But you got to make that initial investment, man. If you want a profit, you're gonna have to lose money in the beginning. It's just how it always works. Well, this was my Excel spreadsheet. See you later.